Just quick word on process. I'll just do a really brief introduction for Brian. Then he'll give his talk, and I think we'll have some time for a question and answer afterwards. Feel free to use the hand raising function, but if you prefer, you can just post your message in the chat, and I can read it in and try and keep track of that. But yeah, to introduce Brian, I don't think he needs much introduction in this community. So it might be actually more interesting for you if I give you a little anecdote that you might not know. When I was finishing my bachelor's degree at UVA, he was just starting as an assistant professor, and he was actually the second marker on my second grader on my honors thesis. And I wish I had kept it, but he said he had some really constructive feedback, and he also said, Jason, I think you have a really promising career ahead of you in psychology. He's not 100% on things like that, but he is excellent at changing research cultures. As you probably know, he's the executive director of the Center for Open Science, which seeks to change research cultures such that they're more transparent and open about how they do their work, ultimately leading to more credible research. I think by any metric, Brian and the COS are succeeding. Researchers who I think would have never thought about opening their data or pre-registering are now doing that. His work in the Center for Open Science's work was recently recognized by the Einstein Foundation for promoting quality in research, which is, I think, very well deserved. It's been involved in many meta-research and open science projects, which I'm sure you're aware of. And finally, he is also a member of the redoubtable Breakfast Brunch in Charlottesville with his daughters, where he's seeking to quantify brunch quality or breakfast quality as well. My pleasure to introduce Brian Nosek.
Thanks much, Jason. That was very nice, and perhaps some illumination for some that don't know all of these contexts. So I'll be happy to give a breakfast brunch lecture should I ever get invited to do so. The data is amazing. The title of my talk was given to me by Fiona Fiddler. The last 10 years, she told me I am instructed to speak about. And so I thought, okay, that sounds like an interesting thing to try to speak about. And I don't know that I have a great vision to encapsulate the last 10 years. What I ended up doing in trying to think about how to present with this is just form sort of impressionistic ideas of what's different in how we're studying ourselves now than how the community writ large studied itself 10 years ago. And so that's, I guess, what I hope to talk about in very general, informal terms about some examples of things that seem different in how we've been evolving our study of our own disciplines over the last 10 years. And I will note, it is the end of my workday. And so my Coke is not just Coke. So this talk may get great by the end. We'll see how that goes, but we'll be happy to have some open discussion about these topics and others' impressions of where we've come and what we've done over the last 10 years. So let me give the overview. This is sort of where I tried to start, is thinking, okay, the last 10 years, well, that means we have to think back to what the world was like in 2011 compared to now. And of course, to understand where we were in 2011 in terms of metascience as a discipline, we have to think about what all of the things that were leading up to it. So the study of research of science is by no means new. It's as old as science itself. And there are many different disciplines with their own norms and approaches and methodologies for that inquiry. Philosophy of science, STS, scientometrics, research methods within different domains, sociology of science, research integrity work, et cetera. And then ad hoc what projects that we would call metascience projects that have been happening for a long time. But Fiona's ask, I think, does feel appropriate in that there's a sense of, at least to me, over the last 10 years, of this consolidating to something that's a new and somewhat different today than it has been in the time before. And so the fuzzy boundaries that I just want to elaborate on and then see how others think about what it is we're doing here is different or unique or distinct or notable in some way compared to how we have done things, is that the world today of metascience, compared with other ways of investigating our disciplines, is a bit more on data and modeling intensive. It's a bit more grounded in the disciplines of study itself. It's a bit more applied. It's a bit more interventionist. It's a bit more collaborative. It's a bit more actually interdisciplinary, and it's a bit more activist. So I want to go to, my talk basically is to just talk a little bit more about each of these with highlight examples that popped to mind as I was trying to think about how to meet Fiona's ask. So let me start with metascience as being more data and modeling intensive than what came before. And this is, the data part feels like, the obvious one in what has emerged as opportunities to examine ourselves from rich, massive data sets that have been accumulating, particularly citation-based data sets. Who references who cites who, how do citations happen, how do literatures form and emerge and break off and do all of these new interesting things. And there's lots of investigations like this. This one example from King and her colleagues, just showing how much better men are than women at citing themselves and how consistent that is over time. They drew on 1.5 million publications across a variety of different disciplines, and we're able to apply very modern techniques to derive much bigger conclusions in much richer ways than we've been able to in the past, with lack of availability or needing to hand code and otherwise such kinds of data. And it's not just that kind of data, it's also modeling exercises like Paul Smaldino and McElreath's work on the natural selection of bad science, in their case, showing that there's no intent needed to produce non-credible research. The system and structure of rewards for different kinds of outcomes is sufficient on its own to produce less credible results over time as the actors are reasonably just responding to the incentives and rewards as they emerge. So this and other examples, like the work by Nissen and colleagues on the canonization of false facts, are applying modeling approaches to questions that we could never investigate experimentally. We're not going to create a system of pursuing knowledge over here and randomize this new system of pursuing knowledge over here and see how the system plays out. Modeling is some of the only ways that we could start to look at what are the presumed features of that system. And if we insert perturbations into that system through the different models, what happens as a consequence to credibility, to progress, to other kinds of insights that we're trying to gain. And that plays such an important complementary role to the experimental or observational evidence of what's happening on the ground, because it can look at the big picture, the biggest of the big pictures of how the system is operating in a way that none of our other investigative tools can offer. So that's an example of data and modeling have just emerged and strengthened over time its importance. The second sort of reflective thought is metascience being more grounded in the discipline of study than historically we have been in the study of ourselves. There's the watcher is the contrast item of a descriptivist observing how a field operates and commenting on it to others of how it is that this work is happening, but never itself intervening or engaged in the discipline. That distance being a value to being able to more objectively observe how it is that system operates. Whereas a lot of the metascience work is becoming very participatory or organized by the practitioners themselves in investigating their own work or the work of their local community. So this example from Christian Kohlberg and his colleagues, where they took conference proceedings from ACM and took code from these many proceedings and said, can we make it reproducible? Can we show that the code that these computer applications had provided with these outputs, can we reproduce the outputs? Should be simple, right? These are all computer scientists. Of course, their code is reproducible. In red are the many failures that they had in trying to build reproducible code from these published outputs. In green are the successful reproductions of that code, building and executing as was specified in the conference proceeding. It was computer scientists trying to figure out how is it that we can do this better. And of course, others in that same field said, wait a second, you did this wrong and that wrong. And all of the debates that we've seen in a variety of fields emerged in similar ways there. But it was grounded in a deep understanding and respect and challenge of how it is that the system operates from within the system in that case. Another example from Ernest O'Boyle and his colleagues in management research, they took dissertations from management PhDs, and 142 of them where they could find a published article of the same research, and they just compared them, what was in the dissertation versus what was in the article. And their particular area of focus was how many positive findings were reported. And the top line result is that the dissertations, same study, dissertations, 45% of the hypotheses had positive results, significant positive results supporting the hypothesis, whereas the same research, 66% of the publications had it. And then they unpack and dig into all of this, saying what changed between the dissertation, research that was already done, and the publication. What stuff got left out, what stuff got added, what stuff got changed. And all of those were occurring to create what they called the chrysalis effect, right? The publication looked more beautiful than the actual evidence as expressed in the dissertation itself. And their ability to do that was very much informed by their depth understanding of the discipline itself and its own practices. And a very similar example comes from Annie Franco and her colleagues, looking at studies that were done through tests. This is a free service sponsored by NSF in the United States, where you can submit experimental studies and to get access to representative samples of US adults. And it's a very valuable resource, but they require, because you get it for free, they'll run the experiment for you, but they require full transparency. You have to publish the protocol that you submitted, and then the data is shared with everyone. And what they find in this investigation is, by comparing the published protocol and the data that was made available with the ultimate publication, that the findings in the publication, what tests were reported from what was done, have 63% of them positive results, have median p-value of 0.02, but a lot of these studies left out certain outcomes. So what gets left out? Well, what gets left out is more likely to be negative results. Only 23% of them, of the things that were left out of the final publication versus what was published, were positive results, median p-value 0.35. So again, it's just another illustration in the exact same as the O'Boyle example in management research of insiders looking at what are our own reporting practices, what are they like, what do we learn from how it is our system works. Okay, so third example is that metascience is more applied, it seems, in 2021 compared to where we were in 2011 for research on ourselves. And there are a variety of different examples. This one's from pre-2021, but it leads to some other things I'll talk about in a minute, of Emily Senna and her colleagues who had a very particular interest that is a very applied interest of we want to improve. And this is in fact the title of the article, how can we improve the preclinical development of drugs for stroke? And the way that they identified challenges for improvement are creating a set of indicators. These are indicators of quality of research. Do they report having blinded? Do they report sampling plans, right? So a variety of different things that one should do in order to have more rigorous research. And then they rated papers on the extent to which they met these quality criteria. A score of 0 did none of them, a score of 7 did all of them. And then they compared that to evidence for efficacy of those studies, right? Their efficacy band there is in the middle, and you can see a very general trend for the fewer quality criteria, the lower the quality of the study, the more likely it is to show efficacy, and the ones that are most high quality showed the least efficacy over time. So for them, this is not just a descriptive exercise. Let's assess the quality of research and say, well, look at that. Research is not as high quality as we wanted. They have a very applied objective. We're doing this in order to find a relationship that then gives us an idea for how we might do better. And Marianne Bakker and her colleagues also did the same about one of the emergent behaviors in the reform movement of pre-registration. So people are starting to pre-register. There's a theory for why it is pre-registration might help with the quality of inference, with the strengthening of understanding what was planned versus what was unplanned, potentially inspiring people to do more rigorous work by getting them to plan in advance. To what extent are people actually following through with the different things that pre-registration offers as a way to provide constraint and clarity on what plans are? And what you would expect here on these many different criteria, which are all numbered, letter numbered, is that if researchers were doing all of the behaviors in their pre-registration to make them highly credible, then you'd see a lot of blue and green. And if they're not in their pre-registrations doing those behaviors so clearly, you would see a lot more gray and orange if they're only doing a little bit. And you can see there's a lot of gray and orange and not so much blue and green yet. And their purpose for this is to say, if we want this action that we are trying to inspire researchers to do, we need to evaluate whether it is people are able to and following through with doing that as well as we would hope in order to meet the promise of it. So these are critical kinds of applied questions because they're directly relevant to whether theory translates to practice and how well it translates to practice. And we see similar types of investigations with regard to registered reports as a new practice for journals to commit to publication prior to knowing the research outcomes. And the fundamental element that that registered reports model is supposed to solve is publication bias, decision-making based on the outcome that tends to favor positive, exciting, novel results. And Anne Scheel and her colleagues compared standard reports to register reports to say, is that working? Are we getting there with what this presumed quality for registered reports is supposed to provide us? 95% of the standard reports find evidence supporting the first hypothesis in the paper. Only 45% or so of the registered reports show the same, directly suggesting that the key outcome is being met by registered reports. We are reporting more negative, null, hypotheses not supported kinds of results with that model. And then extending that, Courtney Soderberg and her colleagues investigated whether this model, registered reports, shows evidence of higher rigor, both because researchers now have the authors have a different incentive. So if I'm going to be reviewed on the question and the methodology, then I better have a really important question and better methodology, and the process. If reviewers can look at and comment on the methodology to improve it in registered reports, rather than just report everything that went wrong, then those two factors may combine to increasing the rigor of the research that's conducted. And across 19 different criteria, when peer reviewers were asked to review a registered report and a comparison article from the same authors or from the same journal, there was a reliable association between the registered reports being evaluated more favorably than the comparison articles. So again, the goal is very applied. There's obviously theoretical rationale, but the purpose is we're doing these things now. Let's see if they're working in the way that we imagine that they could work. Okay, next example. I forgot what number I'm on. Maybe it's fifth, I don't know. Is Metascience as interventionist. So those examples of being applied, of course, we're looking and examining whether these different innovations are having impact. But meta-scientists are also highly engaged in creating the interventions themselves. Let's not just observe how research is happening. Let's try to get new things to happen and see if it has, what consequences it has. Just to illustrate, not yet happening, but just because it's so connected to the prior example, is the possibility of a registered report RCT. This is under review as a second round at NSF, so that we could try to get some actual experimental evidence to complement the observational studies that have been done to date of whether registered reports meet these promises of reducing publication bias, increasing rigor. And to do that, you have to get partnership and collaboration with the stakeholder community itself. So meta-scientists have to be effective and successful at working with, in this case, journal editors and saying, can we create an RCT where you as the journal would be the site, the location for randomization to registered report or standard process. And the way just not to get into all of the details of the RCT proposal, but the basic idea is for areas of inquiry where it's not so uncommon to ask for an additional experiment during review, right? First stage of review, it comes back and says, well, we like what you've got here, but you're missing just a bit of evidence. We want to see one more experiment before we publish it. For those situations, that's where randomization would happen. Either they get the review letter and they have to do their work just as standard practice. Okay, we'll go do our additional experiments and then we resubmit. Or they get assigned to the registered report condition where they get that commitment, you need this extra experiment, but we want you to submit it for review first, and then we'll commit to publishing it regardless of outcome. So the opportunity there is for meta-scientists to really be deeply engaged in the actual process itself in a way that would seem an anathema, decades ago. No, we don't intervene, we observe how things are being done. But really the ethos in the meta-science community, as I perceive it, is much more about, no, we have a goal and let's see if we can work in the system to try to help pursue that goal. And that can be expanded even more broadly. Just staying on the registered reports example, is creating partnerships between journals and funders to co-sponsor registered reports initiatives, where if it goes through a single review process, the journal commits to publishing it, the funder commits to funding it, and the author then has the money and the commitment for the publication. And that does a lot of things to the overall system, potentially, shifting incentives and across multiple stakeholder groups for what authors are rewarded for doing. But then it potentially, as a intervention from multiple different high status stakeholders, could have broader impacts on the overall culture and norms of different researchers seeing, the world is changing, right? These funders in my field care about this kind of activity. Journals in my field care about this activity. I see that it's actually working because these authors are doing it. And that itself may be an intervention to start to shift norms towards greater openness, reproducibility, et cetera. To give a different example, harking back to the Emily Sena's paper on trying to improve stroke or research in stroke, improve strokes. We want better strokes. So the same group examined the impact of nature taking on new policies for reporting standards based on these quality criteria that they had examined earlier, saying if we can get researchers to at least report on these quality criteria, then we may have more confidence in the research that is published, or at least better ability to evaluate it. And so the Nature introduced requirements to disclose, report some of these behaviors. You can see the start of the intervention there, and then across a variety of these different behaviors, the rate of reporting changes over time. And this is a real nice example to me of the basic, what was fundamentally the basic research that had an applied goal of seeing what are the reporting challenges, turning into a potential intervention, a journal adopting that intervention, and then evaluation continuing to see what happened as an impact of that intervention, at least observationally in this case. And then lastly, an example from Ben Goldacre and his research group, where they examined outcome reporting changes in clinical trials that were registered, places like clinicaltrials.gov, and then what was ultimately published. And they found pervasive examples of outcome switching. What was in the registry as the primary outcome was not reported as the primary outcome in the paper. New outcomes were added, and only 9 trials of the 67 they examined here were perfect. Perfect meaning all of the outcomes identified in the registration were reported in the paper that appeared in the journal. So, but that itself is just an evaluation. Are people following through with what the goal of registration is in clinical trials? Their follow-on was interventionist. We're evaluating this so that the community is more accountable to what the idea of clinical trials is, what idea of registration for clinical trials is supposed to accomplish. So they wrote letters to the editors for all of these examples where there was outcome switching, identifying what the outcome switching occurred, and submit it for publication. This should be noted that this trial did not report precisely what they said they were going to report, and here's what we observed. And part of the lesson of this exercise is how few journals were willing to publish these letters, identifying them as low priority or otherwise, and what that might indicate about broader challenges in the system for promoting and engaging accountability, right? If we want to meet the objectives of some of these interventions that are being proposed to improve rigor and quality, and we don't have the system of stakeholders engaged in supporting those interventions to promote adherence in this case, then we will never meet the promise of those. And so there's this, what I perceive as a very strong interchange of the meta-science community being highly concerned with both what is the intervention and then how is it being implemented, and then evaluating whether successful implementations have their intended effects. And if they don't, how might we do it differently and do it better? Okay, I think this is close to the last one, or it's close, whatever. Meta-science is being collaborative. Everybody's collaborative. That's not news, but it seems to be the case. I'll assert shy of good evidence that meta-science is collaborative to the nth degree. It is not uncommon to see author lists like the one on the left, where it is a consortium of researchers commenting in this case on research practice, counter-commenting on that comment on research practice, or collectively pooling resources. My favorite example being the Psychological Science Accelerator, pooling resources to investigate problems that are far beyond the capacity of what any one lab could possibly do on its own. And that not just quantitatively increasing power, but qualitatively changing the nature of questions that can be asked and types of evidence that can be gathered because of the strong willingness to work together as a community to investigate and advance those questions. So I think this is one of the most important things that has emerged. And it's obviously not just the metascience community, but it is, I think, advanced heavily by the metascience community. This notion that if we don't have individual capacity to investigate the questions that are really of interest, then we need to change our approach and do it together. And that is really providing openings for both identifying the weaknesses of current practice and changing pathways to new practices. Metascience as interdisciplinary. Interdisciplinary has been a buzzword for decades of what institutions want to promote. We want people working across disciplinary silos. We recognize that silos are limiting in what kinds of questions we ask, how we ask them, insights, redundancies that occur in ineffective ways. Metascience, of course, as a discipline, offers a functional way to collaborate across disciplines because it is by definition about the science more generally than it is about any particular area of inquiry. But it also creates a mechanism of communication that I think facilitates translation across disciplines in ways that other areas have not been as successful doing. So I'll give two examples. One is the many labs work. So the initial paper is published in 2014 by Rick Klein and colleagues. Had many different labs run the exact same protocols and to look at heterogeneity in effects that might emerge because of variations in sample and settings for a variety of different findings in psychology. And this became a very productive enterprise of saying, oh, we can use this many labs approach, having many different groups run similar protocols to investigate a variety of different questions and learn a lot about replicability, about heterogeneity, about reliability of evidence. So it had a productive course on its own. 5 different many labs projects were conducted by that team, but it also was something that was obviously applicable and extendable to other domains. And so the many label has emerged as popular for a variety of different investigations across areas of inquiry. These are ones that have their own Twitter accounts that I was able to find. The Many Birds Project, the Many Dogs Project, the Many Primates Project, the Many Babies Project, EEG Many Labs, Many Classes Project. And there are a few others that still need to get their Twitter accounts or something, I guess. But the broader point is that it isn't the findings that were interdisciplinary, it's the approaches. And those approaches can be translated and then customized for how is it that we can apply this to these other domains in ways that could provide similar or unique insights there. I'll just note, as Jason mentioned, the Einstein Foundation Awards recently. 2 of these many projects, Many Babies and EEG Many Labs, were nominees for the ECR award from Einstein Foundation. And one of those 2, there was 4 nominees. One of them, the the Many Babies Project, won that award. And so they got €100,000 to support Many Babies 5. They're already on the 5th one. So these are not just, well, we can do these things and we won't get rewarded for them. And they're also showing evidence that these are things that can have high impact and be recognized as important contributions. The other example is also a Many's, but it's a many analysts project. So for different kinds of research situations where we have an existing data set, there could be a variety of different decisions that get made that are reasonable decisions in analysis to identify what we think the effect is. And this initial many analysts project took a data set and had a bunch of different teams analyze the data using their own analytic strategies to test the same hypothesis. And what was observed in that study was variation across the different teams in whether they found evidence showing a relationship between the variables of interest, or whether they found null evidence in null hypothesis significance testing terms. And the purpose was to show that the decisions that we make in the analytic pipeline are consequential. They're consequential in ways that we may not recognize when we're reading a paper and its analysis strategy for how consequential it can be. So exploring the space of varieties of analysis decisions can be helpful in identifying robustness of findings. And that model has been reapplied in really interesting and new ways across a variety of other disciplines. That first one was a psychology-ish data set. It's also been done with neuroscience and neuroimaging data, and economics and organizational behavior and finance. That one just came out like last week, and with sociology data. Again, not on substance, but on approach. Here is a way we can look at some of the practices in our own field and some of the issues that we wrestle with constantly that we can transport easily in a very fundamental, functional, interdisciplinary way across boundaries. Okay, last example of metascience is as activists. Many of these examples already have revealed this notion of not just describing how it is science works, but actually trying to intervene and understand and improve how it is that science works. And that's evident in the research process itself, but it's also evident in the strength of the connections between the researchers, the meta-science researchers who are just trying to investigate and gather evidence about this, and the activist community. And the Venn diagram for these is highly overlapping, of the reformers trying to say, we can do better, and here are things that we're going to start doing to do better. And these are evident in grassroots communities like the open science collaborations that originated in the Netherlands, the reproducibility T journal clubs to promote active engagement and discussion about these issues as journal clubs within institutions. There are 80, 90, 100, there's lots of these around institutions now. There are institutional agents like UKRN, the UK Reproducibility Network, that is a network across multiple universities where they've accumulated buy-in from the institutions to commit resources and promote both training and changing potentially of incentives and reward systems within the university to promote reproducibility. And that itself is extending rapidly across different nations at a national level of reproducibility networks to do the same in Slovakia and Switzerland and France, Germany, Finland, and others. And then those institutional grounding are complemented not just by Amos, by other societies and initiatives that have emerged that are fundamentally about doing better. How is it that we can do better? SIPS, SORTI for ecology and evolutionary biology, STORC for kinesiology, BITS for across the social sciences. And this is where I think is the most amazing. If you think 2011 to 2021, none of these things, none of them existed 10 years ago. And there are thousands of people that are actively engaged and promoting new practices in these communities, that are working together within each of these disciplinary boundaries and across them, and that are supported now by stakeholders that are making these changes more broadly. The Open Research Funders Group is now, it's like 20 different funders now are signed on to this group of making, they're interested in how is it that we can promote and improve, make more rigorous open research. And a huge number, most of these existed prior to this movement, but they are ones that are very strongly supportive on an infrastructure basis for making it possible and feasible for all of these ideas to get translated into practice, make it easier to share, make it easier to have open peer review, make it easier to exchange these data, make it easier to study it. The partnerships between these infrastructure providers and the researchers is fundamentally important for continuing to advance the meta-science goals that we have collectively. I think we're close to where I'm supposed to be stopping, or there already. So let me just close with just some evidence of the opportunity from taking that activist perspective of, is the community prepared to adopt some of these behaviors that are of core interest to the current state of the meta-science movement, right? The things that have been motivating a lot of study. We have been doing data collections on what are trying to be representative samples of different communities with this standardized survey called the Open Scholarship Survey, where we've administered to now, I think, 12 different research communities by sampling corresponding authors from journals from that community, and then having them fill out these surveys. And this is just a simple illustration to note that across 6 different themes that have been popular themes for meta-science discussion: replication, null results, data sharing, otherwise, the degree of favorability across these communities for those behaviors, right? And 87% saying that they are in blue, in favor, very much in favor of replications being reported, 80% of null results being reported. And even the more controversial ones, preprints and pre-registration down at the bottom, you see 54 majority of respondents across these disciplines saying that they favor those behaviors. Many sort of in the middle of the road, and then a minority are saying they're against them. And then when you dig into any one of those, you can see variation across the communities. So in the rows here, I'm showing you the communities that were part of this data collection, where we sample from that community. And from the most supportive of pre-registration in this case to the least supportive. And you can see that a plurality for all of them are favorable to pre-registration. But there is variation across these disciplines, perhaps as a function of the extent to which these reformed communities have been engaged in making progress. And you can then also compare the attitudes that are relatively favorable to how much people are doing the behavior in practice. And this is just a question of, well, think about your most recent paper. Did it have a pre-registration in it? And similar questions are asked for the other kinds of behaviors. And you can see substantial variation across the communities for that. So this is just to say that the meta-science topics of inquiry, the things that both descriptively and prescriptively have been of strong interest and emerging interest over the last 10 years, are also now translating into active engagement by the community that provide that next round potential for what meta-science research can be about, which is, now that people are doing these things, what happens? Does it work? Where does it fail? How does it fail? Where is it now that we can do better? And to me, that is the most exciting part of where we are in 2021 about meta-science, is that we are really now at the point for not just talking about things in theory. A lot of data is emerging to really look at these in practice. And now that we have a community, thank you, Amos, and standards of practice and an active engagement, we can be doing more and more of this, and we're just going to get amazing insights over the next 10 years and beyond. So there was more. I think I'll just stop there so that we can have some time for discussion. If other things come up, I can return to the other things. So thanks very much for the time.
Thanks, Brian. Really insightful reflections on, I suppose, what this field has looked like over the past 10 years and perhaps what distinguishes it from previous work. So anyone who wants to raise their hand or post something in the chat, I'd be happy to read it into the record. I guess I was going to jump in, but Adrian, please unmute yourself.
Oh, I think I've done that.
Yes.
Yeah, thanks, Brian. That was really interesting. It feels to me like a lot of the good stuff is being driven by younger people, younger researchers, and then the older researchers are still kind of resistant, whether that because they've been doing these sort of bad practices for all their time. But they're the ones with quite a lot of power. So how can we sort of harness this great energy we've got from young people and maybe reach some of those older people and get them to change?
Yeah, that's a magical question if we had the answer. And you are right in that, especially in the reform movement, right? The action is in early career researchers. And part of that is inevitable in that the engine of research activity is early career, right? The responsibilities of researchers evolve over the course of their career, where so here's a fact: I have never pre-registered a study myself, meaning I've never gone into OSF and filled out the pre-registration form and hit the pre-registration button. I've pre-registered tons of studies in the general sense, but that's not the action I do, right? The collaborators, who tend to be more early career researchers, are the ones that lead that part of it. So it has to be in some way driven bottom up, as it were, from that hierarchy to enact the behaviors, because that's who by and large more often is going to be doing the behaviors. But your point is an important one in the broader network of, well, we can only go so far if it's only early career researchers that are engaged with this. I'm curious if others have a different impression, but as across different disciplines, where there's more activity, I feel like the energy of the resistance, senior resistance, is more sapped than it is where there isn't that collective action happening. And it's not that they are now on board. It's that now they just kind of wish it went away or ignoring it. And some people will never change. That's fine. The people are going to choose the way they want to do it. But the active resistance is less consequential. Not zero at all, right? There aren't any places where there are instances of no resistance, but that it's weakening in a way that won't stop the growth of engagement. So from my perspective, we don't need to address and solve the recalcitrant. We need to collectively embolden and empower those that are interested in engaging and ready to engage, and provide support for that, because that's how the norms will ultimately shift. There's so many more early career researchers than there are senior PIs. And as long as you can get the rest of the community supporting those behaviors in the general sense, the senior folks will lose in the end that don't want to change. There's much more we can talk about with that, because that's a really important one, but if others want to raise other thoughts on that, great. Thanks for that, Adrian.
While we're waiting for other questions, I'll jump in with my own. It's poorly formed, Brian. Apologies. Yeah, so you mentioned that there's these themes you've noticed in this last 10 years of meta research engagement, maybe modeling, more data-driven methods. Within that really large umbrella of meta research, just research on research, which would include things like STS and history and philosophy of science. Do you see that? Do you think there's enough like a collaboration within those kind of somewhat distinct traditions? Is it something that we even want to encourage more? Would it be useful to see more of that? Do you have any thoughts on that?
Yeah, no, it's a great question, because I think I've emphasized all of this interdisciplinarity, and that simultaneously has been one of the key critiques of Metascience as it has emerged, is not taking enough stock of work that has come before by other disciplinary communities. And is this something new, and what's new about it, and everything else. And I think it would be hard to argue that there isn't something new if only you were situated in the methodology, right? It's easy to agree that some of the questions and themes that get raised are the perennial questions that have been raised for as long as people have been asking questions about how science operates. So those aren't going to be new. And some of the insights gained might not be new, but they may be converging evidence with things that have been offered before through methodologies that were available or are providing that converging evidence, a qualitative approach, an ethnographic approach, et cetera, et cetera. So I think there's great value, and what I've really liked about what's happened over the last year or two in the Metascience movement is a strengthening of those conversations across disciplinary lines. So that I think is really good. The challenge I think that we have to accept as a challenge, if Metascience is to remain interdisciplinary, meaning that many people have their home discipline, but they also identify with Metascience, is that we're not going to all be experts in what each other is expert in. And part of what makes Metascience vibrant is that when you're sitting in a session and I'm presenting something, you say, oh my God, he should know about X, but then you share X because you know about that and I don't. And I think the mistake that we would make is to think, well, you should have known about X, right? That would not be the right call to make. Like, why didn't you study more philosophy of science? Well, because I'm a psychologist, I'm not a philosopher of science. You're the philosopher of science. So you tell me what I need to know about the issue that is well understood in your field that you're expert about, so that we can more productively converse on this topic. So I think it's too easy for us to try to add onto everybody else's expectations better insight on the things that we know. And instead, a more productive Metascience will be, how do I insert and support what you're doing in your discipline over there with the things that I know that I see as relevant, rather than saying you're deficient for not knowing the things that I know. So that's where there's, I think, some potential tensions, but also real opportunities to have Metascience really work functionally as an interdisciplinary field, rather than saying, okay, we have to consolidate what is the canon for metascientists, and we all have to know that canon in order to be metascientists.
Yeah, I couldn't agree more. Normalize not knowing stuff. I think
Really good.
Too good at it. Shinichi.
Hello, Brian. Fantastic talk. Thank you very much. So I was really interested in, you talked about this many labs, many babies, many dogs, many birds. It's fantastic. But you know, the current sort of institutional thing for especially PhD is to do original work.
Yeah.
And you've been involved in those many lab projects. Have you seen the tension? Is there any way to resolve this? Because I certainly believe team science is the way into the future. Yeah.
It's a great question. So I think right now there's a way to leverage the dysfunction in the system to make this possible to be rewarded for. So the dysfunction in the system to leverage is that really the important part of rewards is being an author and getting papers in prestigious outlets. And the cynical way to leverage the many labs work is that you get to be author on a lot of papers that have huge impact, even if you're author number 45. Right? So until the system catches up and realizes, oh, wait a second, that's not what we meant. We meant, you're the one that did that one piece of work. Then we can actually still meet a lot of what the reward system needs to see from us as individual contributors to make these more normative. And so I see it as a subversive opportunity of the many, many, many projects is to really push the system to say, the way we count is stupid. Counting number of publications is dumb because these projects get all these authors that we don't know what they did. We need to know what they did. And all the meta-scientists and reformers are saying exactly, right? You need to know what they did. You don't need to know whether they're an author and what order they're on. So I see that as a really awesome opportunity of those. The other thing I'll say is that my experience in these many projects is that people who are at, shall we say, traditional research intensive universities that need to have, exactly as you say, their original research that they lead. Well, if they can get the right rewards from these systems by being coordinators, leaders of those projects. People who are at institutions that don't have the same degree of innovation push, right? You have to be applying for all these grants, but are at more teaching focused institutions, that are at less resourced institutions. These are great opportunities to get involved and stay involved in research, get the kind of rewards that their institution hopes for, publish a couple of papers, prestigious outlets, that's great. But in a way that is aligned with their capacity in terms of amount of time, amount of resources, and everything else. So a lot of these projects have been really successful because they align incentives appropriately between those groups that have to be leaders because that's what is demanded of them. And those groups that don't have to be leaders would never take on projects like this because they're teaching a 4-4 load, but they love research. They want to stay involved in research. And the reward that they can get from that small amount of contribution to a bigger project is sufficient for both the reward system and align with what they can contribute. So I think there's a lot on the positive side of this. Of course, there's all the threats that you identify and that are well known. But I think this actually the reason I think it's proliferating is because it aligns some of these well with the current system. So thanks for that.
Yeah.
I think we have time for one more question, which is in the chat from Pavel. Brian, do you think that more emphasis on researcher-public collaboration has been a major emerging trend?
That's a great question. Certainly what I didn't mention in my slides is the citizen science movement. And that certainly has been an activity. In my experience, or at least observation, I haven't seen as much engagement between the citizen science community and the meta research community as I think would be possible or profitable. Because I think it's a great idea that there's more opportunities there to expand how it is we engage citizen science, right? Like the most successful citizen science project, I think of things like Zooniverse, which have done amazing things, just sit aside in some ways independently of some of the meta research movements. So that I think is, maybe Rose can bring that up in the next 10 years of how it is we can address that, because I think that's untapped as of now in the ways that we could. So thanks for that comment, Pavel.
And on that note of what's next, we have lightning talks next, but thank you again, Brian. Really, really a wonderful talk.
Great, thanks for having me, and thanks everybody for cheers to that.
Coffee, yeah, here. Thanks, Brian. So the host of our next round of lightning talks is going to be Beth, is that right?